Hello, listeners. As an enhancement to your listening experience, I am now going to present these archive episodes unedited in their entirety, which includes all of my afterthoughts. So, continue listening after the outro music if you want to hear what I thought of the episode. And if you're enjoying the podcast, please support it by going to the homepage, spacerockethistory.com, and clicking on the orange donate button or the Patreon link. Thanks.
Good afternoon. Apollo 10 is now on the far side of the moon on its 12th revolution of the lunar body. And this is the critical time behind the moon, because at this time the two spacecraft should be separating, undocking for the trip Stafford and Cernan will make on a subsequent pass within 10 miles of the surface of the moon, the landing site for Apollo 11 in July. But there has been some trouble aboard the spacecraft, and now at Mission Control in Houston, they're waiting anxiously for the men to reacquire the signal as they come around to the near side of the moon some 13 minutes from now to report on whether they have indeed undocked and whether this mission is to be a complete success or not.
Hello and welcome. This is Michael Annis, and you are listening to episode 195 of the Space Rocket History Podcast. And now, Apollo 10, Lunar Module Testing. The previous episode ended with the crew going into a sleep period so they could be rested for the big day of a simulated lunar landing. Flight Control had planned to let the crew sleep until the last moment on May 22nd, when Stafford and Cernan would leave Young and fly the lander down near the lunar surface. But after playing the song "The Best Is Yet to Come" and sounding reveille, ground control found that the astronauts had stealthily risen, eaten breakfast, and quietly begun work on the flight plan checklist. Cernan removed the encumbrances from the tunnel and zipped over into the lunar module to get everything ready, while Young helped Stafford with his suit, which was a 5-minute job even with assistance. Cernan came floating back into the command module and jumped into his suit. When Stafford and Cernan were ready for undocking, however, they found that the lunar module had slipped 3.5 degrees out of line with the command module at the latching point, possibly because of loose mylar collecting on the docking ring. It might also have happened when Young, during docking, had forgotten to turn off the service module roll thrusters, and Flight Control was late in reminding him of the task. But whatever caused the problem, the crew feared separating the two craft might shear off some of the latching pins, possibly preventing redocking. Stafford and Cernan would be stranded in lunar orbit with no way back except by going out of the lander hatch and making their way to the command module hatch, a dangerous undertaking. But George Lowe, who was in the control room at the time, told Flight Director Lunny that as long as the misalignment was less than 6 degrees, they could go ahead and undock. Here's a clip with a detailed explanation of what was happening.
Perhaps we could go out to Downey, California, to North American Rockwell, where the command module is built, and where their test engineer, Leo Krupp, is standing by, and he can tell us just what the problem is. Leo?
Yes, sir, Walter. The problem has been that John Young was unable to vent the pressure out of the tunnel after Stafford and Cernan entered the lunar module. The problem basically is that when the two pilots are in the lunar module and John Young is in the command module, the two pressure hatches are reinstalled. And then if the tunnel has pressure in it, it's tending to force the two vehicles apart. And at this time, the only thing holding the two vehicles together in a dock configuration is the docking probe, which is preloaded to pull the two vehicles together. But with the pressure in there tending to force the two vehicles apart, there's insufficient coefficient of friction between the two docking rings of the lunar module and the command module to prevent the two vehicles from shifting orientation should any roll maneuvers be performed in either vehicle. And this is obviously what has happened, because Unable to vent the tunnel down to zero pressure, the coefficient of friction has been low, and I believe the last report from mission control has been that the orientation has changed 3 degrees since they originally docked on transposition and docking. Now, the concern here is strictly a structural concern. We could undock at any slippage angle. The problem is the fact that the two vehicles are slipping. We're putting a load on the docking system, on the docking probe. So there will be some concern if we slip past 6 degrees as to whether we have overstressed the probe system or not.
As I understand it, Walter, Leo was just filling me in on some of this. The question is not so much undocking right now as possible damage that might be done these latches and might jeopardize the return when they bring the two back together after Lem's scheduled trips down close to the surface of the moon. Is that right, Leo?
That's right, Bill, and I'm sure the NASA engineers at Houston are looking into this very carefully. At the same time, the North American engineers here at Downey are looking into this.
As I understood Mission Control a moment ago, they have, this is the orbit, the revolution of the moon. They're behind the moon now. There is no signal to Earth. And before they disappeared behind the far side of the moon, this was the revolution that they had to undock on the far side of the moon, if they are to make that sweep over the landing site in the same timeline as the Apollo 11 would make it. And that's quite critical for the sun angles on the landing site, which are quite critical there on the moon, with its sharp shadows and definitions. Now, they have to do it this time. They got a go for undocking. They will make that decision themselves. There will not be another go from Mission Control in Houston. The constraint that Houston put on them was that if that slippage got up to 6 degrees, they should not undock. So if it's not up to 6 degrees, they will go ahead and undock around on the far side of the moon. And as a matter of fact, should be doing that in about 5 minutes from now.
Just before Apollo 10 rounded the corner to the back of the moon, Flight Control informed them that they could undock as long as the misalignment was less than 6 degrees. So, at T plus 98 hours and 12 minutes, the spacecrafts undocked. Stafford and Cernan heard a pow sound as they broke free. Back at Houston, everyone waited anxiously for word on how undocking went with Apollo 10.
Madrid has acquisition now. We'll wait for a good lockup, see whether he comes into acquisition with the television camera on or not.
This is Jack Riley, voice of Mission Control. Madrid has acquisition. Madrid is one of the 3 big ground stations with their 85-foot in diameter antenna dishes. Each of those placed strategically around the Earth.
And we got him right away, Tom. Hello, Snoop. How you doing?
Snoopy, of course, is the Lunar Module.
It's Snoop on Hurricane. How you reading us? Bye-bye. Reading you loud and clear. We're about 30 or 40 feet away from him. Been station keeping for about 5-10 minutes here.
They separated.
Could you give us poo and data? We got a load for you, and you're ready to copy some pads.
They have separated. You're hearing John Young from the command module. So you got them 30 or 40 feet away from him. Just where they're supposed to be. Separation took place. Those were some long minutes, Mission Control.
And I'm ready to copy. Roger, Tino, it's DOI's first pad, and we got 3 pads for you, starting with DOI. I'll read them all through all of them, and then you can read me back, okay? Okay, it's DOI 0 9er. Go ahead. 0 9er 9er 46 0 0.
These are the times for the next maneuvers, and they're getting those cleared away before they go to this television.
9er 9er.
They're giving the time for DOI. That's the descent orbit insertion. And that time of 99 hours, 46 minutes, and 2 seconds translates into 4:35 p.m. Eastern Daylight Time.
Charlie Brown and Snoopy flew in formation through the unfiltered lunar sunlight for about a half an hour. The 2 craft had drifted above the craters while the men prepared for what lay ahead. An hour from now, Stafford and Cernan would fire Snoopy's descent engine and enter a lopsided ellipse called the descent orbit with a low point of only 50,000 feet. On a real landing, at that 9-mile altitude, the lander's engine would reignite for the final descent to the surface. But on this mission, Stafford and Cernan would simply coast along, then soar up to the 215 miles, then swoop down once more. On the low passes, the pilots would reconnoiter the Apollo landing site number 2, a small patch of moonscape near the southwestern edge of the Sea of Tranquility. Then Stafford and Cernan would cast off their descent stage and fire the ascent rocket to rejoin Young. At least that's what was supposed to happen. Now, back to the present. Young, all alone in what now seemed to be an unusually large command module, turned on the television camera so the flight controllers back on Earth could help him inspect the lander.
What are they doing in the lunar module at this moment?
Well, at the present time, they're preparing to make their maneuvers, probably, around to show the command module all sides of the lunar module, a complete check. As you recall, they have already opened the landing gear. It has been deployed. You can, I think, on the monitor that I have here, see the forward gear, and I think you pointed out the ladder going down. These numbers that are being read to them are the numbers that they will enter in the computer and the numbers that they will be checking to make sure that they perform all of the burns correctly, that their updating is proper.
Scott, it's going to be the lunar module that does the turning around, the little pirouette there for Charlie Brown, dancing up in front of him. He's going to remain steady with the television camera, and it's the lunar module that's going to do the performing.
Yes, that's correct. Very similar to the way they did in Jim McDivitt's flight.
Right. Should be pointed out that the space people have grown exceedingly confident of their engineering skills. This is only the second flight in space of a lunar module. It's the first, of course, in the moon environment with its strange gravitational anomalies, in this deeper space in which the command module must re-rendezvous with the lunar module, or these fellows have no way to come home. It's a critical flight in every sense of the word.
With the CSM, we're losing his. We got the downlink to Goldstone, but we're not getting it here in the MCC.
Houston reporting these communication problems.
This column has got to be fixed in the next couple hours, Charlie, so tell them to get with it.
Roger.
That was Tom Stafford, commander of this flight, showing a little annoyance. And everything's looking good there, but annoyed with this ground link communications problem. You just heard Mission Control say that the Goldstone, which is the tracking station in California, is getting the downlink, that is the transmissions from Charlie Brown, from John Young in the command ship, but they're not getting them in Houston.
Meanwhile, the lunar module landing gear had deployed and was in place. The lander's systems checked out well, especially the radar, the abort guidance system, the antennas, and the pressurization of the descent propulsion system. Everything looked good and everybody was ready to go. The next step was the separation burn. Here's the clip.
The command module fires really very briefly, just for about 7 seconds, 6.9 I think it reads in the flight plan. And the separation maneuver is only at it's less than 2 miles an hour, 1.7 mile an hour, just enough to drift apart really a little bit further to give the lunar module plenty of clearance.
Separation maneuver, Will.
And he gets ready to fire his descent propulsion system engine, which is considerable more.
Okay, Houston, coming up on 2 minutes to set. of a sink mark. Roger, we copy. 1 minute. Roger. You're right. Big brother's watching.
Command module mentioned that they had 2 minutes to the burn, and Houston corrected them to 1 minute.
You'll never know how big this thing gets when there ain't nobody in here but one guy.
We're hearing from John Young. That was John Young.
You'll never know how small it looks when you're as far away as we are.
That was Cernan. John Young said, you never dream how big this thing gets when only one guy's in it. And Cernan answered, you never dream how far away it looks. They've got to get back to that command module later tonight in order to get home. The lunar module cannot make the return trip to Earth. It presumably could make it with the firing of the descent propulsion system engine, which has a power up to almost 10,000 pounds thrust. But that would get them out of lunar orbit all right, but they have no way to re-enter.
You can see your thrust is firing there, John, and you're moving away.
Okay. Go 5.3 on the disk scan, 5.0 on EMS, and on 0 on EMS. I'd be inclined to believe the EMS today. We copy, Charlie Brown.
Okay, Jose, so adios, and we'll see you back in about 6 hours.
Boy. Susan, Charlie Brown, we see you separating on the big tube. See you, John Evans. All right. Have a good time while we're gone, Dave.
Yeah, don't get lonesome out there, John.
And don't accept any TEI update.
Trans-Earth injection update.
Don't you worry. Till you get back, I ain't copying any more pads.
What they're referring to is that John Young shouldn't change his return time to Earth such that they wouldn't get back. In other words, don't accept any TEI updates and come back to Earth before they get back and rejoin him.
Houston, this is Charlie Brown, over. Go ahead, Charlie Brown.
So all is going well with the flight of Apollo 10. It's about 6 hours that they'll be apart. As you heard John Stafford say, we'll see you in 6 hours, John. Talking to Charlie Brown, John Young, who now flies alone in the command module. He's got a mighty important job to do, because now with each of the maneuvers of the lunar module, he does mirror image burns or preparations for them, so that at any time he can go to rescue the lunar module if it cannot come back to him. If all goes well, he stays in his roughly 69-mile high orbit of the moon, and the maneuvers are performed by the lunar module. But should, by any chance, they be unable to perform their maneuvers, he has the capability to go get them. But to do that, he must play every maneuver with them in reverse, be prepared at any moment to do what they cannot do in, of course, reverse to get back to them.
At T plus 99 hours, 46 minutes, the moment of truth arrived. It was time for Stafford and Cernan to fire Snoopy's descent engine to enter the descent orbit injection. It would take about half a minute to shift the low point of Snoopy's orbit from 69 miles to roughly 50,000 feet. That timing was critical, for if the burn went even 2 seconds too long, the lunar module would crash into the front side of the moon. Meanwhile, in Charlie Brown, John Young listened in and tracked Snoopy with the command module's sextant, ready to come to the rescue if Stafford and Cernan had a malfunction that prevented them from getting into the proper orbit. At the correct moment, Snoopy's computer flashed 99, and Cernan pushed the Proceed button. The engine fired soundlessly in the vacuum. Stafford ran the descent engine at minimum thrust, which slowly built up past 10%, and then, 15 seconds later, he increased it to 40% for 12 more seconds. The engine ran smoothly with none of the chugging experienced on McDivitt's ride on Apollo 9. Young, in the command module, tracked the burn optically and told the Lunar Module crewmen that they were moving away from him at more than 20 meters a second. Cernan did not think they were going that fast. Rather, he called it a pleasant pace. Almost immediately, Stafford and Cernan sensed the diminishing altitude. Within 20 minutes, they were dramatically lower. The moon's curved edge flattened out as Snoopy flew onward. Mountains appeared on the horizon. As Stafford and Cernan advanced, they could see the mountains were actually the rims of huge craters. Enormous boulders dotted the land. Some looked as big as 5-story buildings. After the flight, Stafford would find out they were 10 times that size. There were cliffs that must have been 4,000 or 5,000 feet high. The mountains of the lunar highlands looked close enough to touch. Keep in mind, all this activity was from the far side of the moon, out of contact with Earth. The command module came around the near side first and informed Mission Control that the Lunar Module had initiated a burn as planned. Here's the clip.
Charlie Brown, Houston, over. Roger, reach last clear. Snoopy was go for DOI. Roger, great. Sounds great. We copy.
Charlie Brown reports, John Young reports that the Lunar Module did perform its burn to drop into the low point.
He'll fill you in when he gets to you, but at 6 miles, he was doing 65 feet a second. On my 6 miles from me, he was doing 65 feet a second. At 3.8 miles, he was doing 73 feet a second. I think that confirms his burn.
In other words, John Young is saying that according to his radar information, computer information.
They're above the rocks, mumbling about the boulders and things right now.
Roger, Charlie Brown.
I saw it rise.
Saying the Lunar Module has slowed down.
They're looking up at the horizon now.
A short time later, the Lunar Module reached the near side of the moon, and suddenly the men were stunned by the sight of their first Earthrise. Now they were in contact with Capcom Charlie Duke, and Cernan's voice soared. Quote, "Houston, this is Snoopy. We is go and we is down among 'em, Charlie." End quote. Down they flew, heading for landing site number 2. Shadows lengthened as they coasted into the realm of lunar morning. Here's the clip.
We should be hearing shortly directly from the Lunar Module, from Snoopy. This simulation shows what the men in the spacecraft are seeing at this point. They are seeing the Earth rising, it would appear, over the horizon of the moon.
Hello, Houston, this is Snoopy.
Right, Snoop, go ahead.
We is down among them, Charlie.
Roger, I hear you're weaving your way up the freeway. Can you give me a post-burn report, over?
Yeah, as soon as I get my breath. Okay, our burn was on time. Our residuals were -0.1, -0.3, and -0.5, and that was the residuals from the dip burn. We did not null anything out. We're at a 61.2 by 9.2, and the AX has us at an 8.6.
Roger, Snoopy. We copy all the residuals, and it looks like we're all go. Your dips is looking good, and it's go. Over.
Stafford and Cernan had studied hard for what they were going to do next. They practiced in a T-38 aircraft. They simulated this trajectory above the Earth. They had pored over charts and maps of the site, and they had scrutinized the area during their hours in lunar orbit. So the astronauts traveled easily down the approach path, calling out the names of craters, rills, and ridges as they went along. They appeared to be traveling exactly over the track they wanted, reaching a low point of 14,447 meters above the surface. Stafford and Cernan were now barnstorming the moon. They took many pictures until Stafford's camera failed as the film started to bind. He described the landing site as much like the desert in California around Blythe. If a lander touched down on the near end, it would have a smooth landing, he said, but if it wound up at the far end of the zone, extra fuel would be needed for maneuvering to a clear spot. Their landing radar worked perfectly when they tested it, and the pilots remarked that there had been no visibility problems with lighting and sun angles. Young, in the command module, caught sight of the lunar module at a distance of 120 kilometers. Snoopy appeared to be running across the lunar surface like a spider. At other times, using a sextant, he spotted the craft as far away as 550 kilometers. An hour after the first descent burn, Stafford and Cernan fired the engine again to shape the trajectory for their return to the command module. Shoving the throttle forward for 40 seconds and 100% thrust, Stafford was happy to note that there was still no chugging. Young tried to see the flames from the engine but could not. Although the lander's speed had increased by 54 meters per second, the crew again had the impression that acceleration was slow. After Stafford's camera failed, he and Cernan had little to do except look at the scenery until time to dump the descent stage. Stafford had the vehicle in the right attitude 10 minutes early. Cernan asked, "You ready?" Then he suddenly exclaimed, "Explicative!" Snoopy seemed to be throwing a fit, lurching wildly about. The lunar module was out of control. Salutations from the foothills of North Carolina. This is Michael Annis, your host, and I wanted to say thanks for listening to episode 195 of the Space Rocket History Podcast, entitled Apollo 10 Lunar Module Testing. I want to give a big shout out to all my longtime listeners. Thanks for staying subscribed, and extend a warm welcome to my new listeners. I'm glad you're here. Make sure you sign up for the email list and connect with me on Twitter and Facebook. You can do that on the homepage, spacerockethistory.com. Today, we salute my Patreon donors. Patreon donors give a small amount monthly to support the podcast. Thank you, Patreon donors who honored your pledge this month. I think we had 100% this month that honored their pledge, and I do appreciate that very much. Thanks a lot, Patreon donors. I had a couple of afterthoughts this week. Well, it looks like I left the episode in another cliffhanger. Will Stafford bring the lunar module under control, or will it crash into the moon? Will Stafford and Cernan release any more colorful metaphors? Will I be able to keep the podcast at a kid-friendly rating? Find out next week. You might have noticed that there were some comm problems on this episode, and Stafford at one point got upset when Goldstone was getting their signal and Houston wasn't. And he told them to get with it. We're out here at the moon, man. Get with it. Also, at the low point of the lunar module's descent orbit, there was another comm problem. And there was just a couple more clips I could have put in, but they were just about unintelligible, so I left them out. But I would have really liked to have gotten those right down at the lowest point of that orbit. The last thing I wanted to say is to mention again that I put a link on the webpage to a free Objective Moon calendar that you can download. Tom Rednor does this every year. It has Mercury, Gemini, and Apollo related significant dates throughout the calendar year. I have one. It is free. so it is available if you want it. There is no cost. It is a PDF file. There are no strings attached. If you want it, download it. If you don't. But I like it. It's a good deal. Okay, now I have a bonus audio clip. This is what I call a bleak bonus clip. This was recorded on Apollo 10's launch day. You'll hear Cronkite in here. And it's about funding for the Apollo program starting to dry up. Here's the clip.
As this Apollo 10 now is on the way to the moon, with the successful launch, the successful firing of its third stage to go into this translunar trajectory, right over here, not very many feet from us, at our CBS News Space Center, at the Kennedy Space Center, at the Vehicle Assembly Building. They're putting the final touches in the Vehicle Assembly Building to the Saturn V rocket of Apollo 11. And George Herman is over there where Apollo 11 is getting ready to roll out to take man for his first landing on the moon. George?
Building, ready to roll out on the pad next Wednesday. If all goes well with Apollo 10, if all the tests that have been conducted on this Apollo 11 for the past 6 weeks are all according to schedule, all check out perfectly, this is the rocket which hopefully will land the first men on the surface of the moon. This is the rocket which will carry man out into space, not for the first time around the moon, but finally to touch, to sample, to see the exact mysteries of the moon, to find out what, if anything, is there that we have not so far seen. This huge vehicle assembly building could hold 4 of these rockets. At the moment, it holds only this one and a small part of Apollo 12. A symbol of what has happened to our space program since the Vietnam War. At one time, it was hoped that this enormous building could hold rockets enough to launch 1 a week, perhaps 1 every 2 weeks, in a giant schedule. Now, only 1 rocket every 3 months. A great slowdown. Walter?
Well, it's quite a slowdown, George, but still it goes forward, and it's really hardly the day for rain on the parade of the Apollo missions.
Please do not rain on Walter Cronkite's parade. Anyway, that is bad news. That was a bleak audio clip. Okay, I posted some pictures and the audio for this episode on the webpage at spacerockethistory.com, and I hope you check that out. Speaking of bleak news, the donations for this past week have fell off the cliff, so to speak. I was pleased to receive one donation to support the podcast. William B. from Australia donated at the Vostok level. Now, we're at 91 patrons still, with a goal of reaching 150 by the end of the year, and the overall total is at 105 with a goal of reaching 300 donors. If you value the podcast, you can make a one-time donation at the homepage, spacerockethistory.com, by clicking on the orange Donate button, or you can sign up with Patreon by clicking the Patreon link just below the button. Keep in mind, Space Rocket History is entirely listener-supported. I depend upon your financial support to keep the podcast going. So if you are enjoying the podcast and can afford it to help, please do so. I would really hope to keep the podcast funded at least to cover all the Apollo missions. I want to cover them all if I can. I really do. Now, keep in mind, you don't have to donate much. You can make a one-time $10 donation at the Vostok level, or sign up with Patreon for $1 per month, sort of like a voluntary subscription. All donors are rewarded with their name on the donors page at the website spacerockethistory.com based on their donation level. I want to encourage everyone and to say thanks for sharing the podcast. Feel free to link the homepage or a particular episode on all social media, and thanks to those who regularly already do so, like my retweeters, that I will recognize at the end of the month. This is the end of content for this episode. If you'd like to stick around and hear some of my off-topic thoughts, that will be fine. Thanks for sticking around, folks. I hope you enjoyed that episode. Next, we will do the continuing story of Apollo 10 and see if the LEM can be brought under control. In podcast news, January was another great month for downloads. It was the third highest month so far. In January, the podcast was downloaded in 88 countries around the world. These are the top 10 countries with the most episode downloads in January. Number 1, U.S. Number 2, UK returns to the second place, very narrowly beating Germany. And Germany is at third place now for the month of January. Australia took fourth place, Canada at fifth. Sweden moved up and took over sixth place. Ireland jumped up to number 7. Brazil moved up to number 8. France dropped a little bit to number 9. And Netherlands are at number 10. Big shout out to all of those listening in those countries. Thanks for downloading. In other podcast news, we are getting ready to celebrate the 200th episode of the podcast. So, you remember how we normally do this. We usually have the Tang ceremony that I've coined that name for it. We'll get a jar of Tang and open it up, mix up some Tang and have a drink on that 200th episode. So if you want to participate, make sure you, next time you go to the store, look for some Tang or another suitable orange-colored beverage. It'll be fun. Okay, that's all I have for this week. I will try to get episode 196 up by next Thursday. So long for now.